Good afternoon, everyone. So welcome to today's panel discussion, which is on the future of software-defined vehicles, or SDV. And we're going to mainly touch upon how the collaboration between SDVerse, Wipro, Intel, and AWS is actually shaping the industry and delivering value to our customers. So myself, my name is Benson Philip. I'm part of Amazon Web Services, responsible for the partnerships in the region for the strategic consulting partners. So with me on stage, I have my fellow panelists. Let me introduce them to you. We have Andreas Tim, Director of Sales in Europe for Intel. We've got Wolfgang Heinrichs, Head of Wipro Engineering Sales in Europe. And we have Prashant Gulati, CEO of SDVerse. So welcome all of you, and let's begin the discussion. So let's start with a very simple question, right? So we've heard the term SDV, or Software Defined Vehicle. So what does SDV mean? So let's ask the panelists. So Andreas, what does it mean for you?
Well, Benson, thank you for the question. First of all, for me, it is very, very important that whatever we do in the automotive industry or in any other industry, we need to put the user, the customer, in the center of what we are doing. Because at the end of the day, when all of us use vehicles, we will benchmark these vehicles. We benchmark these vehicles whether they are an extension of our digital self that we already have elsewhere. We benchmark it versus a user experience, expectations we have, battery lifetime, and also upgradability, software updates, ease of use. Ultimately, you know, the car is benchmarked consciously or unconsciously with this. A smartphone, a device we all use every day. So if the car, the vehicle falls short in that, we do something wrong. Software defined to me means we put something together, a solution that provides an experience for the end customer that is similar to this one.
Excellent. Over to you, Wolfgang. What does it mean for you?
Yeah, in addition to what Andreas just said, the user is in the center of it. But the user is using the software that is being developed for those cars. And don't worry. So, can you hear me much better? Okay. So at the end, we need to manage the software in multiple aspects. We need to manage the various software systems that will be used in the car. We need to make sure that the software continuously communicates seamless with each other and brings the functionality that the car has to use for any user experience, for any situational analysis the car has to do. That goes along hand in hand with how do we handle all these software decoupling from hardware aspects. Yeah? How do we manage these kind of topics between software, hardware, interoperability? It goes into architectures of a car, how the car will be designed as of today to handle all these software stacks that will be used centrally, effectively, with the required performance that is to be used to manage all these aspects. And finally, as Andreas said, is how do we make sure the driver itself can have all these personalized settings so the user experience will be analyzed of that. But Prashant, what about you?
Yeah, so I am a little bit of a history buff, right? So let me just add some history. So cars have had software for 50 years, right? Starting with the Chevy Toronado, Oldsmobile in 1977, right? But what is changing now is that since the 70s, software has evolved, but it always came with ECUs. So you had functionality evolve, but that always came coupled with ECUs. What that means is software was always an add-on. It was an accessory, right? What is changing now is software is becoming the primary driver. Software, like Wolfgang mentioned, we are going towards more centralized and more zonal architectures. and software is getting decoupled. So that, in my view, the most important thing that's happening in SDVs is the unlocking or decoupling of software from hardware, and that is what gives you the faster upgrades and the faster features, because you can't do that if you're just doing ECUs that come coupled with software. One change to one ECU just needs validation of the whole system. That just does not work in today's world where consumer expectations are, very fast over-the-air upgrades, fixes, etc. So software decoupled from hardware, in my view, is one of the most important features for software-defined vehicles.
Thanks, Prashant. So all of us know who Intel is and of course who Wipro is, but can you just in a nutshell say what SDVerse is?
Yeah, so SDVerse is a new initiative by General Motors, Magna and Wipro. They came together last year. Since then we've grown to about 18 other companies, right from FEV, Forvia, HL Mando, TT Tech Auto, NXP, Bosch, Valeo. I mean, all the big names that you can think of, but also some high growth startups. And what we are doing is we've created industry's first B2B marketplace for automotive software, right? And why that is important is the software supply chain does not exist, right? The industry has perfected the art of buying hardware boxes that come coupled with software, but in the SDV world, you can't go find software. Like we've done some white papers for each software component, and remember, in today's architecture, there's about 1,000 to 1,200 software components in each car. For each component, companies take about 16 weeks to find one software, right? So, and we're bringing that 16 weeks down to a few minutes or a few hours, right? So, if you're an OEM looking for park assist software to battery management to tire pressure monitoring, you can come into our platform, search for it. We'll show you the companies that are providing those softwares. You can compare, you can reach out to sellers, you can issue RFIs on the platform. So, like I said, we've helped OEMs save about 80% time in sourcing.
Excellent.
That's what SDVerse.
So a matchmaking platform.
It's a matchmaking platform at its core. Yeah.
All right, good. So with that, I think to the next question is, I mean, how does cloud and especially AI play a role in SDV? So we'll probably start with you, Andreas, on this.
Yeah, absolutely. So cloud is super critical and AI is super critical in this because, my smartphone example, all of the devices, smartphones, laptops, any edge device today is connected somehow, connected to a cloud, connected to the internet. And it is really important to have a cloud solution in place that meets these requirements in the device, in the vehicle for our automotive discussion. And therefore, I'm super excited that Amazon Web Service and Intel have announced a collaboration, a strong collaboration over multiple years with billions of dollars of investment, where Amazon Web Services will use the latest Intel chip technology in the data center. So you will use the Xeon processors that many people see in data centers or in the cloud service providers basically, and will have a customized solution that we work with Amazon in order to do that. You will also use a processor based on Intel's 18A technology. That's our latest and greatest technology, leading edge, in order to make sure that the AI services in the cloud are there to support what happens in the device, in our conversation, the vehicle, to provide that user experience that we all know and love from modern laptops, from modern smartphones. So thank you for that collaboration, by the way. It's a pleasure.
It's fantastic to collaborate with you, Andreas. So I think the same with you, Wolfgang. I mean, from your perspective, and especially from as a large global system integrator, how do you see the role of cloud and AI when it comes to software-defined vehicles?
Yeah, let me touch upon what Andreas was saying, connectivity, right? There are meanwhile hundreds of sensors within a car that need to somehow communicate with each other. Means there is a huge amount of data that will be collected. On the other side, the car is talking to the outside. So it's inside and external communication. And in this kind of respect, you need to have an environment to handle all this data. That is why Wipro is strategically partnering with you, Amazon, because you have these kind of web services, data spaces, performance available for us to handle all this kind of data. To give you a real practice example, in a customer environment where a test driver is running typically with the car around and checking all the functionality, the car in 2-3 hours roughly generates 5-6 petabytes of data. And the software needs to be able to really understand what this huge amount of data is all about and which are the essential parts of the data that have to be analyzed, validated, cross-checked to make sure the car is functioning as expected. So there is a huge requirement to bring this data as fast as possible to the cloud, make sure the data analytics or the data annotation is running across this data to identify the 5, 6, 7% of the data that is really required to cross-check if all those functions are acting and performing properly. So there is a huge demand on cloud, and we are happy to partner with you on that aspect. Coming to the AI part of the story, you need to make sure you have algorithms in place that have an AI aspect to predict what kind of potential failure can occur in a certain circumstances to make sure the car is ready to upfront detect an idea, an information, there might be a failure and take the required actions. You can't do this with standard algorithms. So AI is essential for these kind of topics. Another topic is any kind of ADAS functionality has to have AI integrated to really be able to have situational analysis, place the right decision as early as possible, far before a human person is able to predict what is going to happen in 3 seconds from now. Just as an example for cloud importance and AI importance.
Thank you. So that already sounds very complex, right? So that's coming to my next question. So I'm sure in this whole journey, you're going to face a lot of challenges. So what are some of the key challenges that you have faced in this journey and how are you addressing them? So I'll start with you, Prashant. I know you already touched upon some of it in your introduction, but if you can elaborate on some of the challenges that you've seen and how you've addressed.
I mean, maybe if you will allow me, like I just wanted to add a point about
Okay,
AI.
sure.
I mean, this was a very interesting discussion about AI. Like there are safety applications, there are efficiency use cases. One of the things that I think is very important and evolving is agentic AI, right? AI agents, if you will. I mean, AI became mainstream with ChatGPT. What is ChatGPT is you have your phone, which is hardware, you have an operating system on top of it, you've got connectivity to the cloud, and you have an application, right? Today, or in the near future, almost every car is going to have all of this, right? The AI and cloud capability. What stops us from having agents like ChatGPT in the car, right? And so there's a lot of work being done, and I'm pretty, very looking forward to that. So, tons of use cases, and I'm very excited about. We talk to OEMs a lot, right? And the kind of work that's happening behind the scenes is it's pretty mind blowing, right?
Definitely.
So that also leads to the next question, which is what you were asking. What are the challenges, right? It's like you said, it's a lot of complexity and cost involved, but in my view, there are 3 broad categories of challenges, right? Number one is software-defined vehicles because they are so new. They need new architectures, right? So we're going from domain control to centralized or zonal. That needs capital investment, right? Number 2 is, so number 1 was new architectures. Number 2 is new tools and processes, right? New tools like engineering tools, like what we just talked about, is cloud and will need a CI/CD pipeline, right? And number 3 is newer culture, mindset, talent, if you will. A lot of companies have, established companies have the capital, the know-how, but have struggled with SDVs mainly because of the culture and mindset. Meaning, you can't just take with all respect to engineers, an engineer working for 20 years in one department, you just move them to go define software now. It just doesn't work like that, right? And that's where partners like AWS are super helpful in coaching, educating, training new companies. But the most important, and which is where we are very focused as SDVers, one of the most important processes that does not get talked about is supply chain, right? So there's a lot of work in engineering and manufacturing, but not enough on supply chain. We talk to a lot of OEMs. They are figuring out how to do a software supply chain, right? And so that, I think, is one of the biggest challenges, because like I already highlighted, you want to go find software. You want software in the car, you can either do it all by yourself, which is not capital efficient at all, and it destroys the supply chain, or you can go find it. To go find it, you go to conferences, you Google, you talk to suppliers. It's a very unstructured analog process. And that's what I was saying is takes about 3 to 4 months to find one software component. So that's a big challenge, to take an unstructured analog process, convert it to structured and digital, and that's what we are solving for at SDVerse.
And how are customers, how are you solving this, and how are the customers benefiting from this?
Yeah, so instead of going one company at a time, we are doing this for the industry. We are setting up a supply chain for the industry, right? So right now, if you go look at Ford, Stellantis, GM, BMW, everybody has their own supply chain that buys parts for their technology stack, right? We think, and we've done the work, there is opportunity for reuse in software across the board, right? So you don't have to custom develop software for each different model, each different brand. So we're bringing sellers and buyers of software on one platform, right? So sellers list their software. They provide us a lot of information about their software, which does not exist on their websites or on Google, right? So they'll tell us what operating system is their software on, what level of certification, what maturity, what real, so 180 plus attributes. And that is very helpful for buyers like OEMs to come and find software. So let's say if I'm an OEM and I'm looking for parking assist or lane change assist, and I want it on Linux and I want it at ASIL level B, right? They log into SDVerse and they're able to see all the suppliers, and you can't find that information online anywhere, right? So, and so that's how we are solving it. We bring people together and find information and kind of take it from there for sourcing.
Got it. So maybe let me hear from your perspective, Andreas.
Well, I believe the biggest challenge that we have, especially in Europe, is speed in the automotive industry. And I don't mean fast cars, right? We have a lot of super fast cars, fantastic. I mean the speed of development. How long does it take to develop a car? That, for a typical European car, that's 4 years, 5, 6, up to 7 years. If I look at China, it takes 12 to 18 months. Up to 7 years, under 2 years. That is a big difference, and we have to address that. The speed in which the Chinese automotive industry is moving, that is computer industry speed. This speed we have to adapt, and we can only do that if we rethink how a car is designed and how the ecosystem around the car is designed, so that we are defining things through the software and not through the hardware or fixed functions in the car that cannot be changed easily. We need to enable the car, the vehicle, and the ecosystem with the cloud to be flexible in order to get to this computer industry development speed. That is super critical to stay competitive.
Excellent. So Wolfgang, your perspective.
It's a good starting point for me as an engineer by heart. Yeah, it's all about speed. I 100% agree to Andreas. But looking to the audience, I see a couple of senior people here, but I still see a couple of young talents compared to my age here. But in the early days, you have developed software to get the best out of the hardware resources possible. So you develop software specialized on Andreas' chipset, right? Now in SDV, we just talk about the opposite. We decouple software from hardware, but you need to still get the maximum out of your hardware performance in order to transact all these millions of calculations the software is forcing you to do. So we need to bring an environment to our engineering customers that allows them on one side a virtualization of the hardware design, on the other side a virtualization of the software design, bringing those both virtual worlds together to have an integration analysis to get a feeling how much performance I can get on my chipset that I will use in the future versus how many millions transactions I have to calculate on it. And that is one of the ways to address Andreas' topic of speed. We can't wait until the physical chip is designed and then I can test my software, figuring out the performance is bad or whatever else is going to be bad. So it's all about virtualization. And coming back to my initial statement, virtualization means you need to have space, you need to have performance, and that means without a cloud environment that supports the virtual chip design and the virtual software design, bringing both virtual worlds together, simulate accordingly, can only be done in a collaborative cloud environment.
Very good. All right. So, so I think we have touched upon some of the key aspects on what is SDV, how does cloud and AI play a role, and what are the key challenges and how we are addressing them. So, with that, I think the last question around, like, so what are some of your key takeaways from your experience in this journey? So let's go around and hear from the panel. So I'll start with you, Prashant.
Yeah. So for me, it's three simple concepts: innovation, collaboration, and capital efficiency. Right? And I keep emphasizing the capital efficiency. We talked about innovation being user at the center, like Andreas mentioned. Collaboration, SDVerse is a classic example of industry collaboration. We have 18 companies that have come together so far, right, to solve an industry problem. But capital efficiency, I think somebody's called this coming 10 years a Darwinian decade, right? And so I think everybody here and in our circles, resource allocation, capital efficiency should be the most important aspect. The industry spent about $40 billion on software last year. That number is going to double every 6 or 7 years, right? Are consumers going to pay double of what they're paying today? Absolutely not, right? So capital efficiency, innovation, collaboration, capital efficiency are key themes for me to drive as a business leader.
Very good. Wolfgang?
I gave one example just beforehand about the complexity of it, but if we think through, we all know cyber is around us. There is no way around. So we have to find ideas, solutions, approaches, how to make sure our software gets much more reliable, secure against any kind of external cyber attacks, especially in the SDV environment where a car is run most by software rather than by hardware anymore. But this is definitely increasing the cost significantly for our OEMs, right? They have to spend much more efforts to make the software secure, to make the car secure, make the sensors secure, make the communication car to X secure. So our customers are really in a challenging situation to balance the additional cost for development, the additional cost for integration, the additional cost for verification and validation, and of course, additional cost for the maintenance. And it's a little bit of a tricky situation to get that money paid back by the customer who is expecting cars getting cheaper. Yeah. That's my takeaway for SDV.
Great. Thank you, Andreas.
So my takeaway has to be, again, user experience first. That is the mantra. In order to get there, from Intel, we offer for the car manufacturer specific chiplets, graphic solutions to put that in the car. And with Amazon Web Services, for example, we offer a developer environment in the Amazon Web Services cloud so that the car manufacturers can test and build all this software experience in the cloud before it ends up in the car, so that the development cycle is shortened. So user experience first, and we have to get there with a lot of speed.
All right, thank you. So thanks to all the panelists for their exciting insights. It's definitely clear that the collaboration between Wipro, Intel, SDVerse, and AWS is actually enabling the future of SDVs. Right. So thanks for the audience. If there are any, we have time for questions. Maybe we could take one question. I think that'll be.
Gentlemen, thank you so much for this insightful discussion. It was really nice. So my question is open. How do you see the business models evolving, especially for this AI-powered SDVs? And most important, what's the ROI for automaker they are investing into this transformation?
So I can try. First of all, I think the business model, first of all, is to stay competitive in the automotive industry for the car manufacturers. My example of Europeans, 4, 5, 6, 7 years to develop a car, Chinese, under 2 years. Let's utilize software-defined vehicle to stay competitive. And then the second aspect, how can we evolve from there? Remember my smartphone example? When Steve Jobs introduced this thing, there was no app store on this. Maybe they thought about it, maybe not, right? But it developed over time because they were not thinking hardware necessarily, they were thinking software and software defined. So that to me is competitiveness and evolving business models and user needs that we can keep up with if we're software defined. I hope that helps.
Thank you so much, Andreas.
Yeah,
Thank
another aspect is maybe if you look, let's say, roughly 10 years back, right? The overall business model for the automotive industry was B2B driven. The OEM produces the car, brings it to the dealer sells it to the end customer. With being software driven and far more software is being developed for the car, it's changing from a B2B model into a B2C model where the OEM directly leases or rents a car to the end customer. And as Andreas stated, there will be subscription models to make sure once the car is being sold from the OEM to the end customer, you can subscribe additional features on the software by just spending some money over time. If this model will be a successful model, it has to be proved. So far, at least from what we hear over the automotive industry, SDV is not yet really in the positive area of an ROI. It will take some time.
Thank you.
Thank
Any
you.
last comments?
Yeah, I think so. The SDVs is, I think it's very much important for the industry, right? For like Andreas mentioned, for cost savings to be able to bring down cycle times, but also the creating new profit pools, right? Companies make money today through parts, labor, service, right? Over time, parts are going to go like fewer parts in the car. Fewer service requirements in the car, less labor in the car. So the profit pools are going to go away, but SDVs will open up subscription opportunities, content consumption opportunities, which I think, and for the life of the car, which I think is going to create, like I said, newer profit pools. So a ton of opportunity, which is why almost everyone is moving towards software-defined vehicles.
Thank you so much.
All right.